Pi is one of the most fascinating numbers ever discovered, so famous that every year on the 14th of March it has its own special day to celebrate. So what is pi? Pi is one of the most well-known mathematical constants. It is the ratio of a circle's circumference to its diameter, and for any circle the distance around the edge is just over 3 times the distance across and is usually rounded to the figure 3.14. Pi is incredibly useful for all kinds of simple and complex calculations, and at school you learn how to use pi to calculate the circumference and area of circles, as well as the surface area and volume of cylinders, spheres and cones. But what about pi in the real world? Well, there are lots of jobs and people who use pi on a daily basis. Pi is used frequently by engineers, so let's take a look at some real-life examples presented by 3 real-life engineers.
Hi, my name is Aileen and I'm a final year chemical engineering student at the University of Edinburgh. I'm going to tell you today about how pi is used by chemical engineers. So the first thing to address is, what is chemical engineering? Well, chemical engineers design and operate processes to transform raw materials into products. This means that chemical engineers are involved in lots of the things that we use every day. For example, chemical engineers design processes for pharmaceuticals, water treatment, food and drink production, fuel, and lots more. So how is pi used by chemical engineers? Well, lots of equipment that is designed by chemical engineers is cylindrical, and so we need to use this equation to find the size of the equipment that is required. For example, heat exchangers are used to cool fluid down or heat it up, and distillation columns are used to separate mixtures of different fluids. And as you can see, both of these pieces of equipment are cylindrical, so we need to use pi. As well, pipes are used to move fluids between processes, and so pi has to be used to calculate their size. Thank you very much for listening.
Hi, my name is Alex and I'm a tunnel engineer for Atkins. I use pi in maths and physics at school and ended up studying those subjects for my A-levels. I then went on to do a degree in civil engineering at university. Now I use pi regularly in my day job where I design tunnels and other underground structures. On to the first example. So most tunnels nowadays are circular, basically big hollow cylinders and made of concrete rings, with the rings assembled together to make the tunnel. Each ring is made up of curved segments, as you can see in that diagram. In this case, there are 5 segments per ring. In order to make the segments, I need to know the size of each segment, and to do that, I need to know its curved length. I therefore use the internal diameter, d, of the tunnel, and multiply that by pi to find the tunnel circumference. I know that I have 5 identical tunnel segments, so to calculate the curved length, L, of one of those segments, I just divide my tunnel circumference by 5, and that's it. For the second example, many of the underground structures I design are made of reinforced concrete, which is basically concrete with steel reinforcement bars running through it. The steel bars are circular, and they're required to help give the concrete more strength to stop it breaking apart. I need to work out the number of steel bars that are required in order to give the concrete enough strength. And to do that, I have to calculate the total cross-sectional area of steel bars. The area of one steel bar is pi r squared, where r is the radius of the bar. Once I've found the area of one bar, I multiply it by the number of bars, in this case 14, to find the total cross-sectional area of steel within the concrete.
My name is Lauren and I'm a civil engineer on a construction site. At work, I use pi when I need to calculate the volume of stone in a trench that has a pipe in it. Have a look at this trench. How much stone do you think is in this if it's 10 meters long? Let's work it out. First, work out the volume of the whole trench by multiplying the length, which is 10 meters, by the width, which is 1 meter, by the depth, which is 3 meters. This equals 30 meters cubed. Next, work out the volume of the pipe by timesing the length, which is 10 meters, by the area of the pipe face. Now remember that the area of the pipe face is found by multiplying pi by the radius squared, So that is pi times 0.25 squared. Finally, you take away the volume of the pipe from the volume of the trench, so that's 30 minus 1.96 metres cubed, which equals 28.04 metres cubed, and that's the answer.
We hope you enjoyed this short video. Thanks for watching. If you want to find out more about Pi, take a look at the official Pi Day website.